Leetcode question 934, shortest bridge. You are given an n times n binary matrix grid, where 1 represents land and 0 represents water. An island is a four-directionally connected group of ones, not connected to any other ones. There are exactly 2 islands in the grid. You may change zeros to ones to connect the 2 islands to form one single island. Return the smallest number of zeros you must flip to connect the 2 islands. Let's take a look at the example. Example 1, 0, 1, 1, 0. So the output is 1. You either flip the top left one or you flip the bottom right corner. Then you will form a connected single island. Example 2, 0, 1, 0, 0, 0, 0, and 0, 0, 1. In this case, you must flip 2 zeros. You flip those 2 zeros, the ones on the bottom right or the middle right. So if you flip those 2 zeros, then you will form one connected island. Example 3, you have the surrounding ones, and then you have a single one in the middle. In this case, the output is 1. You either flip the cell to the left, right, bottom, or top of this middle one. You can form one single connected island. I also came up with another example. So in this example, basically you have one connected island, even it has one dangling cell here, this island is still connected, and then you have another island on the bottom right corner. So in this case, the output will be 2. So if you flip those 2 zeros, then you will form one single connected island. So in order to solve this problem, we need to answer the following questions. The first question is how to distinguish between island cell on one island from the other. So basically, let's take a look at this example. How do we know, okay, all those ones belongs to one island, and then the other one belongs to the next island? So the answer is, first we need to identify all the island cells on one island first. We can do this by traverse through all island cells on one island, and then add all those cells to the set called visited. So basically the first idea is, okay, let's try to traverse through all the island cells on one island first. And once we visit the island cell, we just add it to a set visited to keep track of that. In that case, we know the remaining island cells not visited belongs to the other island. So in that way, we can distinguish between the two islands. So another question we need to answer is, okay, move from one island to the other. How to exclude the island cells and only count the water cell? So basically, let's say, okay, now we have identified all the ones belongs to this island. But what if I start with this cell, and then this cell on the first island, and I'm trying to reach the other island. So as I'm moving, how do I know, okay, along the path, let's say if I move this way, this way, this way, I can reach. So move all the way to the right and move all the way to the bottom, I can reach the other island. But how can I exclude all those island cells that belongs to the same island from the calculation? So basically that is, let's say from this cell, we can move all the way to the right and bend bottom to reach the other island. And then we encounter multiple cells that belong to the same island. And then we also encounter 2 water cells. And then these 2 water cells is actually the output, that is 2. So in the calculation, we must exclude all the island cells we encounter that belong to the same island from the calculation. So in that case, the answer is we track steps. We only increase the step when we encounter a water cell grid. And then how to find the smallest number of zeros to flip. So this is equivalent to smallest or shortest distance. So the first idea is BFS. So to recap, in order to solve this problem, we have 2 steps. First step, we identify all the cells belong to one island. So we first identify one island. In order to do that, we can use the DFS algorithm. We start with the island cell. Basically, when we encounter grid value of 1, and then we identify all the ones belong to the same island using DFS. And then after that, the second step is we use BFS to actually solve this shortest path problem. We start from the identified island, move to the other island. The steps it takes to first reach an island cell on the other island is our shortest bridge. So let's code our solution. Okay, step 1, DFS, step 2, BFS. And then let's have a visited cell. So visited is an empty set. And then let's have the DFS algorithm. Basically, we start with ij. Before actually writing the DFS, let's get our n. So this n is the length of grid. And then write our DFS. So basically, if ij in visited or grid ij equals 0 or I less than 0, let's say, okay, actually let's put this one first. First check if it is out of boundary. If I is less than 0 or I is greater than n minus 1 or j less than 0 or j greater than n minus 1. So this is out of the boundary. So if it's out of boundary, we just return. Or if it's not out of the boundary, but this has already been visited before, we also return. Or it has not been visited before, but it's a water cell. So in that case, we'll also return. So basically return. Otherwise, we can continue visited. So in that case, we just add visited dot add ij. We start visited this cell. And then for x, y in, basically we need to identify the next cell. So that is x I plus 1, j I minus 1, j I j plus 1, I j minus 1. In this case, we can call DFS x and y. So that is our DFS function. And then for the BFS, and then let's do the BFS function. Define BFS BFS. And then for BFS, we're actually going to use a queue. So basically, well, we first form the queue. This queue is our visited. So queue is our well, we have a queue, and then for all the elements in the queue, for all the elements in this range length queue. I will explain so what we are doing right now. So basically, So initially the queue has all the visited island cells. Basically, that's all the cells belongs to one island. So that's the elements inside the queue. So basically, for BFS, we are trying to pop elements from the queue. So in that case, queue dot pop left. So we are actually pop our ij. So ij. And then initially we also need to have the steps. We set it to 0. So we pop element from the queue. And then for if less than 0 or I greater than n minus 1 or j less than 0 or j greater than n minus 1. So in that case, we just continue. But here, let me write it this way. So if 0 less than equal to I and I less than or equal to n minus 1 and j if it's within range, so in this case, let's actually add for x, y in if it's within the range, and this great and then x, y not in visited, in that case, q dot append x, y, and then visited dot add x, y. And then in the end, after we check all the elements, we increase the steps. And then in the end, we just return steps. Okay, so basically what does this do? So this is basically initially the queue has all the cell belongs to one island. And then why I'm using this for loop, it can be a little bit confusing. But here the idea is using this for loop is, let's say, once we get the initial state of this queue, we want to first be able to pop all the initial elements from this queue before we increase the step. Because let's say in this example, initially the queue has all the island cells of one island. And then basically we want to finish popping all these cells and cells and then add all the adjacent cells if the adjacent cells are not outside the boundary and are not visited before, that means, okay, that is one step. So we want, basically from all the island cells, we want to move all one step simultaneously. So in that case, that's why we want to first check all the island cells. That's why we need this line. This Q, this will not change as we are actually updating it inside this outer for loop. So basically, this is just, okay, when you call the while, and then we get this initial state of the Q, and then this is the length of this Q. And then inside, on line 869, when you update it within the its for loop, it will be captured next time when we call the outer for loop, let's say for while range length Q. So basically, the overall idea is, in summary, for each step, right now we haven't moved one step, so we want to consider all the initial cells, and then after move one step, what are the cells after we move one step? And then we want to consider all those, and then similarly after move two steps. So that's why it has this for loop on line 65. So now let's code our main program. So for the main program, that is for I in range n, for j in range n, we want to first if grade I j is 1, it's an island cell, then we want to call DFS ij to first add all the cells from this island to the visited. And then after that, I just want to return the BFS. Basically, after we identify one island, we just want to call BFS. So for call BFS, I forgot to code one thing within this BFS. That is when I need to return the steps. So I think I made a mistake here. So I only return the steps when I actually reach the other island cell. That is if grade ij that is, let me code it here. If grade x y is 1, in that case, I return steps. So this solution is accepted. Let's take another look, trying to recap the main idea. So I made an update to this BFS function. So basically for this BFS function, we first have a queue. Initially, this queue has all the cells from the one island, basically all the grid cells, all the island cells from one island that's in our visited after the DFS. And then we set initial steps to be 0. And then we basically for each iteration, while this queue, for each iteration, we want to check all the cells in this queue belongs to step 1. So basically, belongs. What does it mean? That means okay, continually. Currently, this queue has all the all the grade cells at step 0, and then for moving one step, what are the cells we can move to after moving one step? That will be the next iteration in the of the elements in the queue. So basically for the current iteration of the elements in the queue, we first pop up the elements, and then we check the next cell we can move to, and then to check if they're out of the boundary, we want to make sure they are within the boundary, and then they are not visited before. In that case, we can consider, okay, for this xy, grid xy, if it has already reached the other island. That is if it equals 1. It can't be the cell in the same island because for all the cells belongs to the same island, they are already added in the visited before. So it wouldn't satisfy this condition. So when we encounter a grid equals grid cell with value of 1, that must belong to the other island. If that is the case, we reach our destination, we just return the steps. Otherwise, we just append them to the queue, and then we also update the visited. And then after we check all the cells belongs to the current step, basically after this 4 in range length of queue, we just increase the step by 1.